My presentation is Viz Walking in a Multi-Modal Wonderland. And with this, I'm going to focus on a project that I've been working on for probably better than 5 years now. This is the Southwest Corridor Light Rail project. So I'm the traffic engineering lead on this project, and this is Portland's next light rail extension. You can see the green dash line here on the left. This is heading out towards Tualatin and Tiger, and this will pick up quite a few large employers: the Oregon Health Sciences University campus, Portland Community College. It's a very heavy commuter corridor and definitely the most challenging light rail project with a lot of topography compared to the rest of the network that's been built to date. So we'll be focusing on the Gibbs Station specifically, which is the first station out of downtown. This is the highest ridership station along the line. And it's uniquely situated on the hill between the split OHSU campus. Again, this is a big university hospital. The main campus is up here on top of the hill. You can kind of see in the image up here. The big buildings up here. They ran out of room on the hill, and about a decade ago started building out a campus down on the river, the south waterfront. These two campuses are connected today by an aerial tram. So if you're familiar with Portland, you may have seen the big silver bubbles going through the sky between these two. Very heavily used aerial tram for just patients, students, doctors, and campus workers between the two campuses. It's also used quite heavily by tourists, so it's a very popular tourism attraction as well. And so our light rail line, unfortunately, doesn't connect directly to either campus. We're right here on Barber Boulevard, kind of situated in the middle. And so we have to find a way to get our light rail ridership to either one. And so we have a trail system with a large pedestrian bridge over the freeway that connects to the south. And then we have this Markham Hill connector, which is kind of a side project that'll provide an inclined elevator or funicular connection up the bluff to connect into the trail system and bus circulator to the Hill campus. Ridership this station, I mentioned this is the highest ridership station along the line. A little over 6,000 daily trips just on and off the rail, and nearly another 8,000 trips on and off the bus. So we also have a large bus station here as well. So the Markham Hill connector, again, this is our solution to get those passengers up the hill. You can kind of see a conceptual rendering here. I like to call it a funicular. It's definitely more fun, but technically it's an inclined elevator because the two cars can operate independent of each other, so it's not an old counterbalance system. They'll hold about 40 passengers each and run just under 2 minutes for the run here. And so you can see here we'll have this median station. It'll operate both with buses, light rail. We have very high passenger use. There's even some regional trails that connect, kind of hiking trails through the system here that'll be crossing down through here. So all kinds of multimodal users, protected bike lanes. So this is the solution to connect into one of Portland's largest employers. Here you can see another conceptual rendering, how we separate out the buses and light rail. I'll dig into that in a little more detail here in a minute. The other interesting part of this is the shared transitway. So as the rail comes into downtown, we hit to this orange line here, and this orange line segment is a shared transitway where we're actually running buses and light rail all on the same lane. So it's effectively a paved track. And part of this is due to the right-of-way constraints that we have through here. So it's a historic neighborhood, a lot of registered historic properties, very expensive right-of-way. And so that's a solution to provide not only the light rail through here, but also to provide sort of a priority and express treatment for the buses. So this is an incredibly congested area. One of the, basically the South Knuckle enter into Portland here. There's very little parallel routes, and so it's congested today. It's only going to get worse in the future. Light rail isn't going to fix it, but it'll provide an alternative to it. And we didn't want to have our buses stuck in that same congestion. So that was our solution with the shared transitway. Both coming out of the transit mall in the downtown end and at the start of the transitway, buses will have a place where they'll effectively pull into their own pocket. It happens to be a station as well. And then they'll be given a signal to enter the transitway. And TriMet, who's the regional transit operator, has standard operating procedures that in these shared environments, which there's a couple already within the system, buses can follow a train, but we can't have a train follow a bus. So in that case, we need to make sure we have controlled entry. Within the shared transitway, we have 2 light rail stations, but only 1 bus stop, and that's at the Gibbs Station here. And with that, the bus pulls off the transitway. You can see here, the bus will be on the left side of the platform, the light rail on the right. And so that way we never have a bus stopping once it's on the transitway directly in front of a train. So the buses will just drive through the Hamilton light rail station. So there's no bus stops there. So that's the general concept of the shared transitway. So within our V7 model, we have various transit controls, almost kind of like block signals for the train. We have various technologies that we're using to keep those separation throughout. Again, just sort of another schematic here. You can see here, the yellow platforms here are where we'll have the dwelling with the LRT on the right, buses on the left. And we have this cross section right through here. So just to give a cross section profile view, you can see we have our buffered bike lanes, and these will actually end up being protected bike lanes. Just about any new bike facility along arterial level facilities in Portland needs to be protected, so not just buffered, but have some sort of physical separation. That could either end up being a raised protected bike lane, it could be some sort of curbing, candlesticks. Generally, there'll be some sort of actual protection beyond just the buffer. We have our vehicle travel lane. Today, we have 2 lanes northbound, 1 lane southbound on this street. So we'll definitely have more congestion combined with the growth of constricting traffic into a single travel lane. We have our trackway, our station platform, and then our bus lane, and then the opposing directions. So very much a multimodal environment here. And then bringing this into V7. So how do we figure out all these operations? Because we have a lot of challenges here, a lot of different conflicts that we need to separate. It'll largely be controlled by signals. So this whole complex with the Gibbs Station is modeled with 1 RBC controller. So what we have is 6 crosswalks, 2 light rail phases, 2 bus phases, and 2 vehicle bike phases. So the general flow is passengers will get off of either the bus or the light rail into the center platform here. They'll cross over into a central island, and so that'll be a signalized crossing between the platform and the central island. And then there'll be another signalized crossing that where the passengers or the pedestrians at that point will cross the transitway. So that'll be the bus and rail, and then the vehicle lane, vehicle and bike lane. Because of the rail operations here, we can't have just openly yield crosswalks. Everything has to be signalized. And then we also have backup platform crosswalks that are signalized as well. So we went through a variety of concepts to figure out how we want to operate this. As I mentioned, we're constricting northbound traffic into a single travel lane. So especially in the AM peak, very high flows, it's going to be quite congested. City's all right with the level of congestion, but we want to maintain as much throughput as possible. So we have that to balance with one of the highest ridership stations or the highest ridership station, and how do we make sure we minimize pedestrian delay? We don't want to have pedestrians wait a long time to cross the bus lane and then wait a long time to cross the lane of Barber. So we got to make sure we have reasonable pedestrian progression as well as minimizing pedestrian delay. In the end, we ended up coming up with a solution that used a single controller with 4 rings, 10 phases, 8 overlaps, and 2 preamps. And so we could have, if there's a bus that's ready to go, and a light rail ready to go, the light rail will override and preempt the bus service. And we also have to make sure that when the rail's ready to go, it has to wait for any pedestrian clearance time. And then also southbound, we have another signalized intersection just outside of this. So the light rail is held at the station until both the Gibbs Station signal and the Whitaker signal are all sort of locked and lined and ready for the rail to proceed through without waiting. So this was quite a challenge to get this operation kind of optimized, but VSIM was incredibly helpful in getting that operation set up. And then moving on to the Viz Walk V7 setup. So we had initially set out to do a Viz Walk model. So this was something that we didn't have scope and budget for, and we really didn't have schedule for. But as we were working through the various design iterations, it became quite clear that there was going to be some challenges. So as we kept shrinking the footprint of the station, we were seeing potential constrictions for pedestrians, and we're starting to wonder, is this actually enough area to move this demand? And so we were able to crunch a few other tasks to get just enough budget to add in the Viz Walk component. And so we did kind of a bare bones setup here, but it was enough to provide a lot of a great sort of insight into the design process. So the basic concept with VSIM, if you haven't used Viz Walk before, to link Viz Walk to VSIM, it's done through the transit module. And so you have your transit stops or your PT stops. You define a platform edge, which is part of the Viz Walk area. And then you define a waiting area. So that's really where the passengers are going to exchange between the VSIM transit vehicles and the Viz Walk area environment that they'll travel through. And then you use pedestrian routes to get the pedestrians on and off the transit vehicles to either other parts of the network, or into this example here, we also have routes that go to the inclined elevator station. So the other thing that TriMet was interested in is, how does the platooning of pedestrians getting off of the inclined elevators, how does that impact the operations and the flow through the system? So again, we're working on a shoestring budget here. It would have been great if we could actually, with a 3D model the funiculars moving through, having the passengers get on and off each funicular as we have with the transit system. But sadly, we had to do this kind of fast and cheap. So with this, we have all the pedestrians being generated off the funicular, and we had a lot of good data on those estimates based on TriMet's ridership models, how many passengers we have coming off of the hill, which the hospital on the hill is affectionately known as Pill Hill. And so what we did is we set up a signal here that would basically mimic an arrival of a funicular vehicle or an inclined elevator vehicle. And so every couple minutes, we'll get a platoon of vehicle or platoon of pedestrians coming out of either side of the station here. And then the passengers coming off of the transit vehicles coming towards the inclined elevator, rather than just having them disappear off the network, created kind of a holding spot here so we can kind of mimic that crowd of the queuing, because there'll be basically a queuing space for pedestrians to line up, and then they'll enter either to the left or the right, depending on which car is available. So this was really helpful, so we could see those platoons of 40 to 60 passengers coming down the hill. And then for the remainder of the presentation here, kind of just talk through as the video plays. And of course, when I tested this ran just fine. All right, let's try this. All right. Bill, just to verify, are you guys able to see the video play?
Yeah, we can see it great.
Okay, excellent. So here we're looking north. We see the bus just pulled off the shared transit way to the left of the platform. We'll see the passengers get off the bus. So we did have to use the passenger flow model with the transit assumptions. See, the bus will then place its call, wait for the pedestrians to clear. And so a couple interesting things about the design here is you see this domed building. This is a historic synagogue that the congregation actually sold to TriMet in 2018, and they're perfectly okay with TriMet demolishing this building, because originally this is exactly where the inclined elevator was going to end. You can see here just on the left, the light rail station light rail train just pulled up. But the community has had an issue with this building being demolished, just because it has kind of unique architecture. And so while, you know, from a legal standpoint, TriMet is perfectly within their right to tear down that building, there's just some political sensitivities about whether that stays or goes. And so this concept here, where we're showing that it stays, this ended up pushing our crossing further south. And you can see here how we get this cluster of pedestrians kind of in the point of this triangle here. And we had to skew the crossing to go a little further south here. And so these constraints was really pushing all the pedestrians into this one little area. And this is where Viz Walk was really able to help show the team leaders at TriMet, as well as the designers, that, hey, we can't keep constraining the environment this much with this level of pedestrians. And so that was really the big benefit of using Viz Walk for this project. And so we're looking for solutions. We might change the design here so the pedestrians cross more into the middle. Initially, this central island was almost twice as big, but it impacted a historic property just off the screen here. And so it's a really helpful tool in helping us balance these constraints and what will the pedestrian environment look like once this is all constructed. So you can see our pedestrians here, cyclists. The one thing that Viz Walk doesn't model well, or at least I don't know how to model well, is the how many passengers are going to run right at the end of that flashing don't walk. And you can see here, again, doing this on the cheap, we were able to get some of the design elements from the urban design team, but we don't have the full digital elevation model in here. All right, and then here's our light rail train. You'll see the doors open, the passengers get off. Again, the volumes that we have here are all based on a pretty detailed ridership assessment. Get another bus coming in. So the way that the progression worked through here, it worked quite well to have the passengers get off the train, they progress onto the central island, and then they're basically held on the central island while the train goes through. So I'll go ahead and pause there. That concludes my presentation. I'll go ahead and open it up to any questions.
Excellent, thanks, Randy. Very interesting, both technically and just as you know, someone who lives nearby, to see the planning and the stages that it's in. That's great. So we'll see if there's one or two questions that pop into the box. So far, we don't have any. Just from a magnitude of distance scale, Randy, for the project itself, the distance once the person would go up that incline until they can actually make their way over to the aerial tram is still something. Is that an area that you guys needed to model from a Viz Walk perspective at all, or what's the pedestrian connection like between those two?
So it's once they get to the top of the inclined elevator here, there'll be a bus stop for a circulator bus that goes around the various campus destinations. And then it's about a little over 600 feet, about 2.5 downtown city blocks. Portland has very short block lengths at 200 feet to tie into the bottom of these various buildings. So then you have a series of elevators to get up. You know, there's almost effective like 15 to 20 stories worth of building in here. So you could usually tie into the bottom, and then there's a series of skywalks and bridges and elevators to get into the various locations.
Okay.
And then about double that distance to cross down to the other station. There are places further upstream where pedestrians can debark off the LRT and get on more of a local bus that'll take them directly to the door of the South Waterfront.